Okay, I think we're going to begin. If anyone joins, the first few slides are just, hopefully for most of you, a brief overview. So, what is Git? It is what this presentation is all about. Git is the most commonly used version control system. A version control system is any system that allows you to understand the history of a file and how it has progressed. Kind of like Google Docs revision history. So for example, when you edit a file, Git can help you understand or determine exactly what changed, who changed it, and why. It tracks changes you make to files, and it keeps a record of your work, and it lets you revert to earlier versions of your code if the need arises. It's not the only version control system, but it's definitely the most popular. Many programmers use it daily, and understanding it will be very beneficial for your work as well. And beyond that, Git dramatically improves collaboration, allowing multiple people to work in sync on the same source code. For those of you who just joined, we're just quickly making a brief overview of what Git is. We're on the first slide. And a common misconception that I've seen is that GitHub is not Git. GitHub is a website for hosting or storing projects that use Git for free. Are there any questions on that? Feel free to drop them in the chat or just unmute and ask anything. If not, we'll move on. Okie dokie. So for those of you who are still a little confused about what a version control system, look to this image on the left. It's basically just different versions of your files. And on the right, we have an XKSD or CD comic, for those of you who know what that is. So we're just going to have a brief overview of what we'll do in this workshop today. We're going to install and set up Git on our computers if we haven't already. We're going to create GitHub accounts to store our work for free. We're going to learn and utilize several essential Git commands. And we'll discuss Git on the command line and through various interfaces such as gitcachin, GitHub Desktop, or Sublime Merge. And then we'll create, initialize, and push a repository. And then we have a lab at the end. I do want to emphasize one more thing before we begin. This presentation has a lot of commands to remember. You do not need to remember those. At the end of this workshop, I'm going to give you all what is essentially a giant cheat sheet. What's more important in this is that you understand the concepts that we're talking about. Okay, so initially my plan was to have us all download and create GitHub accounts now. Before I decide whether or not we're doing that, can we see, like, in the chat, who has done this already? So if you haven't done this already, say that in the chat. Because if everyone already has, then we don't have to do this stuff. And if most people haven't, then we'll probably do it at the end. I have the slide again there. You do not have to do this right now if you don't have Git at all and you're brand new. Don't worry, this lecture is going to have stuff for people who are completely new to Git and also for people who have some experience but are learning or hoping to learn more. I've only seen 2 people say anything, so either you're not paying attention or I'm going to assume you all have Git and we'll move on. Oh, hey, a poll. How did I do that? Thanks, Ben. I'm going to guess Ben. So GitHub Desktop, there's a question in the chat. What is the difference between Git and GitHub Desktop? GitHub Desktop is a GUI, a GUI, or graphical user interface for GitHub. it is not Git, but it's a way to interface with it. And we'll talk more about that later in this presentation. But that means you have used Git before. So most people have. We'll discuss this more later then. Okay, let's get the basics. So this first part is the stuff you'll use on a regular basis. So Git, saving checkpoints of your code and sharing them with others. This is the fundamental function that all of Git revolves around. And it's important to kind of understand that this is the fundamental concept. So the next thing that I think many early Git tutorials kind of gloss over is what Git actually looks like. And they just jump straight to commands. I think it's important to kind of be able to visualize what you're doing. So Git structure, I know it looks a little complicated to some of you, but basically what you want to be looking at is this blue line, which is the main history that you have. And each of these dots is a single checkpoint on that history. You can consider it a save, a version of your code. And then this little spot that sticks out here, oh, whoops, is a branch, which we'll discuss more in detail later. But the main thing to take away from this is that GitHub and Git in general use structures that look like trees. And that the main tree is called the main or the master branch. And that's how we'll refer to it from now on. For Vivek, who just joined, the main thing we discussed was what we were going to do in this lecture and what Git is. It's a version control system. And for those who want to get deep and dirty, it can get pretty complicated, but we're not going to go that right now. So this might be the most important slide in this first section, which is basically what are the commands that you'll use to create a new repository. And I want to first say that a repository is basically just a folder or a project of code. And whenever we say repo or repository, that's what we're referring to, because that's what Git calls them. The other thing I want to note before we delve into this page is that to use Git, you use the CLI, which is command line interface, or terminal. If you've ever seen the black box with the little blinking cursor, that's how you interface with Git. And I know that this is probably pretty simple for many of you, but I want to try and make this as open as possible. So you use Git by typing in a terminal, and all computers have one pre-installed. You can go to the Finder or the Start menu and type command or terminal. You can also access the terminal by right-clicking in the directory of your file explorer, or clicking Open Terminal, or if you're on Windows, you can replace the path with the word CMD or command and click Enter, and it'll open the terminal right in that directory. The most important concept to understand is that we are creating a repository and pushing it to the cloud. And that is what this, at least part of what this slide does. So Git init initializes a new Git repository locally, which means on your computer, it makes it so that you can use other Git commands in that directory. Git add all, or git add dot, adds all of those files to the staging area, which basically means they're ready to get committed. And I'll just get into that right now, which is that git commit takes those staged files and basically does save as for Git. You commit files to the remote repository, and a commit is a named checkpoint that represents an individual set of changes to your code, like saving your changes with a unique ID that allows you to keep a record of what changes were made when and by who. So commit is probably the most used command in Git. And there are some practices that you should follow. This is basically what not to do. I am often guilty of this myself, but especially if you are collaborating with others, it is very important that your Git messages are meaningful. And I do like 30% of mine, like add edit UI or something But this is not what not to do, basically. Pushing and pulling. So this is the second half of that slide we just looked at, which is we created our repository, we added our files, and we committed them. So we made a checkpoint. How do we get them to GitHub or the remote repository? The remote repository is like the cloud. It's where you're saving your files and not on your computer. So git add remote origin. This command basically adds the upstream repository to publish your commits at. So you push your changes to the remote repository or the cloud with git push, and then there's different variations on that. And then the alternative to that would be git pull, which basically takes your changes on the remote repository and grabs them and synchronizes them back with your computer. And why you would want to do that? Well, let's say you're working with a friend on a project. You make your changes, you push them to that remote repository, the cloud, and then they can pull them back from that repository, and suddenly you have the same code on two different computers. It can even be two of your computers if you want. If there are any questions, remember, feel free to leave them in the chat or to just unmute and ask them. Oh, we're getting more people now. Anyone who's joining right now, basically what you missed is the first major commands that we'll use to create a repository, and we'll review those later. And just what Git is, it's a version control system. So getting existing projects, there are a lot of Git puns in this presentation. So what do we do if we want to not create a new one, but get one that's already in the cloud? Well, there are three ways to do that right now. And the easiest way is probably just to fork it. And what forking does is it creates a copy of someone else's repository, and it's on your account now. And it keeps their history, but also basically creates your new version of that, and you can compare them. Cloning, however, is the command line way of doing things, where basically what you do is create a local copy of a remote repository, whereas forking leaves it on the cloud still, but it's your cloud instead of theirs. And that's done through the GitHub website. You can also download the zip file if you really want to, which is the third way. So part 2, let's get good at this. Okay, branching out. So we talked about branches very briefly at the beginning, but a branch is when you have that main history and you decide, I want to add a feature or a change to that history without screwing up whatever's on the main branch. So it's basically a named checkpoint like a commit, but it's no longer in sync with the main history, which lets you make changes and test code without breaking things. Branches are commonly used, like I said, with testing new features or collaborating with others in order to not mess up their code. These are some commands we commonly use to do that, like git branch, git checkout, which changes your local version of Git to that branch, and so on. So this is what a branch looks like. We have the master tree, and then little branches pop off of it with the little features of the big features. And what this basically means is this purple dot, for example, has the same history of this blue dot, but is no longer connected to the history past that. So it's basically an entirely different version of your project. Merging and stashing. So here's a common scenario. My friend and I make changes to a repository or a code project. When I pull his changes, I end up with merge conflicts. What's a merge conflict? Well, let's say I edit a file and delete a huge swath of it, and he edits that same file and adds a ton. Well, when we smush those together, you're going to have some problems, right? His is missing a lot, and mine is now has a ton that I didn't add. And those are called merge conflicts. So my local code and the code in the remote repository are incompatible, and I will need to go through and manually decide which version to keep. Git offers a few commands for this: git merge, which does it automatically and recursively, and git stash, which stores my local changes. Like, let's say I deleted a portion. I can store that part for later, so those changes, that portion comes back so that I can combine my code with his, and then I can redo that part where I deleted that portion afterwards. And that's what these commands do. So let's go back to our diagram. That's basically what this looks like. You have your main tree. We have our branch that pops out with the feature. Each of these dots, keep in mind, is a commit or a checkpoint in our code. And then we combine them back together into one tree or branch with a merge commit. Okay, it's time for the nitty-gritty. This is the stuff that you could Google, but we'll cover it to understand more. So I'm actually going to change to, let me go over here. Not you. To YouTube. I guess I closed it. Show you guys a depiction. So this is a depiction of the Git history of a complex repo that I worked on with a friend for over a year. And if anyone wants to try and tell me what we're looking at, okay, I see that it's loud. I can mute it or just turn it down a lot. I don't really know how Zoom controls that. Does muting it make it better? Okay. So does anyone want to try and tell me what we're looking at here based on what we've talked about? I know it looks a little more complicated than some of the diagrams we just looked at, but this is basically that on a much larger scale.
Branches?
Exactly. Yeah. So each of these, the main tree, as you can see, is this big guy. And then you have all of these branches popping out of it, where each of these little dots is a commit. And this is over, I think it was a year's time, but you can see how this relatively simple structure can grow and become very complicated over time. We'll switch back to the presentation. That, okay. So, comparison, status, and inspection. So these commands are not relevant to taking your code and getting it onto the remote cloud like we have before, but rather enabling us to interact with our code and our revision history within our terminal of the directory of the project that you're working on. So git status, for example, lets us see details about the current branch. What files have I staged to commit? What commits are ready to go? Is the current branch up to date? Is there anything to commit? Are there files created or deleted or modified? What is the history? And that's what these do. It's very useful. And honestly, I don't use them enough, but very useful to do. So someone asked in the chat a lot earlier, what is the difference between Git and a GUI, a graphical user interface for Git, like this? This is GitHub Desktop, Git Kraken, Sublime Merge, there are many. And really the difference is, I guess, this is a way to kind of understand what's happening, where you're just using a button press rather than from the command line. It's just an alternative way of doing that. And initially, I relied very heavily on things like GitHub Desktop or Git Kraken, just because I didn't want to mess around in the terminal. I thought that was very scary looking. But honestly, since moving and trying to really learn how to use the terminal, I found that it's just significantly less powerful in the ways that you can handle those kind of complex issues that you run into with larger projects. but it is a good way to visualize what's going on. And if you're having trouble with the terminal commands, these are a great resource for you to use. I have some links down here that you can look at later. We're going to get a little complex now, though. So these are commands for people who already know basic Git, but they really haven't delved too deep. And I guess before I really discuss what these do, I want to give you a practical scenario of why you would use these. So git rebase, we already talked about merging. Let's say, or this is an actual example of when I used one. A couple weeks ago, I had this repository with 400 commits in it, and 20 of them had a password. This is a private repository, but I want to make it public. Now, naturally, you wouldn't want to make it public with that password in the history, because then anyone can see the password. It's exposed and they can use it for whatever they want, which is not great. And so one way you can handle that is with git rebase, which basically reapplies commits on top of another commit. So you can take 5 or 6 or 7 commits and you can go back in them with an interactive rebase and basically alter entire lines of that code, changing the history. This is a dangerous thing to do because if you screw it up, you'll alter your history. But luckily, with Git, you can undo almost anything. There are very few things you can't undo if you screw something up, which is why it's very useful. But this is a depiction here where you can take a branch and rebase it onto the master. And with that, it effectively acts as a merge, but without the merge commit, if that makes sense. If anyone is confused, again, feel free to leave questions in the chat. Even if you're totally unsure about what's going on, it doesn't matter. I really want to make sure that anyone is able to grasp these concepts. Cherry pick is more straightforward. You're cherry picking 1 or maybe 2 commits, and then you can either delete that 1 commit or move it around or edit it. And this graph on the side where we have this little A, B, and then we take F from the middle of this feature branch and we cherry pick it onto the top of the master. So it's now even though it was on this other branch and totally unrelated to the history of everything else, we just moved it to the front of the main history, which is where you would be looking at it if you were working on a computer. Pull requests and issues. So this is more of a concept rather than a command, but a pull request is a place where you can compare and discuss differences introduced on a branch with reviews, comments, and tests. And it basically allows you to ensure the code is up to par before merging it with the main branch, and it helps you collaborate with others. You can create and fill in issues under repositories. This is pictures of GitHub. Issues are exactly that. They're just ways to track your issues and what you need to work on for your projects. So this slide, the essentials. If you take anything away from this presentation, it should be these commands, because these are really the ones that you'll use the most. Git status lets us know all the necessary information about the current branch. Git clone makes an identical copy of a repository that's someone else's or yours and saves it on your computer. Git commit is the most used command. It sets a checkpoint in your code history. Make sure you add the files first. Git branch creates a local checkpoint that's no longer in sync with the main history. It allows collaboration or features, and it uses this command, git checkout, to switch to a new branch. Git push or pull, and those quite literally allow you to push code to the remote or pull it back to yours. Should I be working on my master branch in my dev environment or make a new branch? I think that this is really more of a best practices question than really as far as just is there a set way to do it? You can kind of do whatever you want with Git. It depends on what project it is. So like on personal projects like mine, often I will just work on the main branch unless it's a very massive feature, or it's a project that's already in production. So for example, if it's an app that has, 2,000 something users or whatever, you don't want to be working on the main branch, because if you screw something up, that you have now ruined your like currently functioning history. So if you're making big changes, you'll want to go onto a branch for that. But if you're just working on a website or a project that isn't like actually out there yet, maybe it's private, maybe it's public, you can just work on your main branch, like whatever's really easiest for you. However, Git really is built for branching. Like that is one of the most central concepts to Git. And therefore, like there's really no downside to using branches other than better organization. And even if you're like not super comfortable with it yet, doing it over time will definitely help you become more comfortable with branching. I hope that helps. Okay, so we're to the lab part of the presentation. I'm going to send in the chat a couple links. So if you don't have Git or GitHub already, what I want you to do is go to these links, download Git on your computer and install it, and then create a GitHub account. So Git, let me just double check what this does. Oh, that's your, I think I have that actually in the presentation. Yeah, that is, thank you, Alex. That's in the repository. So the other thing that I want to send again, sent at the very beginning, is I've created a repository for this event that once you have done those two things, I want you to pull up on your computer with the Zoom, or just open and look at. And, oh, not that again. Let me go to it. What that does basically is, let me close the other tabs. So this is what GitHub looks like. And this repository is the cheat sheet I spoke about at the very beginning, and has some information, but it also has every single one of the commands we discussed with explanations to what they do and what order you can use them in. In addition to several commands I didn't talk about that will be hopefully helpful to you guys. Another thing that this repository includes is a bunch of resources, like the one that Alex just sent me. Actually, I don't know if that is in, it might be. I know I have this thing here, Visualize Git Under the Hood, and the Visual Git cheat sheet, which both of which are very similar. But basically, like if you're still confused about something after this presentation, or you want to learn more, these resources are very good guides that I've all gone through before. Okay, so before we move on from that, let me go back to this. While people are getting their Git installed, are there any questions whatsoever? Feel free to unmute and ask them, or just put them in the chat. Absolutely none? Wow, I must have done a good job. Either that or everyone's AFK and I'm just talking to a wall. Okay, cool. So if everyone is ready to move on, and you all have GitHub accounts and have Git installed, we're going to start discussing the lab. Okay, and even if you're still installing it, you can do that in the background. We just quickly discuss this. So this lab is meant to really be an encapsulation of all the stuff we talked about for both beginners and people who are somewhat experienced. and also give you at least something useful out of this, even if you didn't learn anything. Cool. Okay, so most people have it installed already. So what we're going to do is I've created within the repository that I shared with you all, so hopefully you all open that up. There is a folder or directory called docs, and we're going to look at that right now. Let me just open it up in an extra tab. So if we click on docs right here, you'll see that within this directory, we have a whole explanation of what the lab is. Yes, let me send the link again. So within the docs directory of this repository, we have this lab. And so what we're going to do is we have this profile demo website that's been created. It's a basic portfolio that has a resume in it. If you guys don't have one already, that is something useful to you. So what we're going to do is we're going to copy the repository that I've created using one of 3 methods, which I've detailed in full here, with all the commands or things you can use. You can pick which method you want to use. They each have their own upsides and downsides. For example, downloading the file is quick and easy, but you lose the history. Forking allows you to compare your history, but takes an extra step. And cloning requires you to change the remote origin. It does not matter which method you choose. Pick whatever you find easiest. And then you'll just follow the commands and directions is here. I'm going to walk through it with you guys. And there is a bonus challenge for anyone who is more experienced. Within the index.html file, there is a dummy API key. So by completing the lab as normal, which you'll do first, you're simulating an API key or a password being accidentally exposed, which is a common security breach that I've done many more times than I'd like to admit. So for the bonus challenge, what we're going to do is try and remove all traces of this credential from our history. You must include the API key in the initial commit, and you can use git commands to remove the API key from your history. If you don't know what an API is, which I probably should have explained first, that's an application program interface. It's just a password, essentially. And that's what you need. The API key is a password. So there are many ways to accomplish this, but unlike with the first part, I didn't tell you how. There's a hint that you can click on if you need it. Now, notably, I do want to emphasize this. If this was a real data breach and you pushed an API key or a password to a public repository, it's too late. You should still do the above, but you should also invalidate and reset that API key or password to something else safe. And this site that I have available here is an altered template from something else. So you're going to copy the repository, use the git commands that we've learned to push it to your own GitHub account. And if you know web dev or web design development, you can alter it to your liking. If you open up the file, I have a bunch of comments telling you how to make it look however you want. And then the third part of this lab is we're going to use GitHub Pages, which is a free hosting service for static GitHub sites, to make it live. And I will show you guys how to do that as well. But basically, you go to the settings of the repository and click source docs, and that's it for GitHub Pages in GitHub. The other thing I recommend you guys do is star the repository for future reference. You know, it is a really valuable cheat sheet for all of your git command needs. And you can do that by just clicking star up here. So yeah, if you guys have any questions or comments, I just realized I probably shouldn't run through it because then I mean, I guess I can. There are 3 ways to accomplish it. So it doesn't matter which way I do it. So I guess I'll run through the lab while you guys are doing the same. Yeah, I'll run through it one of the ways. So the other thing I want to mention before we through the lab is that if you're a student and you have GitHub, which you do if you did this presentation, make sure you sign up for the developer pack because it's so much value. You get the JetBrains IDEs, you get Unity, you get DigitalOcean free hosting, you get Heroku free hosting, you get Mongo database free hosting, you get free domains, you get pro accounts for all kinds of stuff. Like, it is ridiculous how much free value this is. If you're a student, you need to sign up for this. And there's so many people not taking advantage of it still. So highly, highly recommend. There is literally no downside. I think you just have to give them like your school email.
Thanks for watching. We hope you enjoyed this video. To learn more about the FAU Developer Student Club and stay up to date on our events, visit dscfau.com or check out our Discord server at dscfau.com/discord.